Which of the following compounds will produce a basic solution when dissolved in water? Okay, so let's take a look at these salts, figure out did they come from a strong acid or a weak acid? Did they come from a strong base or a weak base? If one of these was produced by a strong acid plus a weak acid plus a strong base, that strong base wins, giving us a basic salt. So let's take a look at what all we have going on here. Sodium nitrate. The acid that nitrate ion would have come from is HNO3, which is strong, and the base that the sodium would have come from is NaOH, which is also strong. So that means the solution will be neutral. Ammonium nitrate. Ammonium came from the weak base ammonia, and nitrate came from the strong acid HNO3. And so we have a strong acid with a weak base. So this is going to be an acidic salt. KCl. The K came from KOH, which is strong. The Cl came from HCl, which is strong as well, so this one will be neutral. NaF. The Na came from NaOH, which is strong, and the F came from HF, which is weak. So since one is strong and one is weak, the one that's strong will tell us the pH. The base is strong, so this is a basic salt. Okay, so that one is looking like it's probably the right answer, but let's look at the very last choice as well, HCl. Always think about what you're doing. If we started to treat this one the way we treated the first 4 answer choices, we'd break it down into the cation and the anion. But this one is even simpler because HCl itself is a strong acid, and so this solution will be acidic. We don't have to analyze that any farther. Just always be on the lookout for one odd compound being thrown in there like that. All right, so for this one, it says when sodium acetate is dissolved in water, the solution will be acidic, basic, neutral, or we need more information to answer this. Okay, sodium ions. The base gives us the cation, so this would have come from NaOH, which is a strong base. And so the sodium ions are perfectly stable. They don't want to react with anything. They don't want to react with water. Acetate came from acetic acid, which is a weak acid. So the acetate ions don't want to stay acetate ions. Instead, they will opt to react with a molecule of water. And since that's the solvent, there are plenty of water molecules available. It will deprotonate the water so that it goes back to being acetic acid. You could even think of this in terms of a tug of war over that proton, and acetate is stronger at grabbing the proton or hanging onto the proton than hydroxide is. Hydroxide, being a strong electrolyte, just lets it go. And so that proton transfers over to the acetate ion, leaving behind a hydroxide ion. That hydroxide ion makes this solution basic. As a follow-up on that previous question, which one of these reactions is going to be responsible for sodium acetate being a basic salt? And just glancing at the 3 reactions and looking at their product side, only one of these is showing hydroxide on the product side, and that is indeed going to be the correct one. The acetate ion doesn't want to stay acetate. It wants to steal a proton from water and go back to being an acetic acid molecule, and in that process it liberates hydroxide ions. All right, one more kind of interesting clicker question here. I slipped one compound into this list that we have not talked about today, which is CO2 and what that does when it reacts with water. And our instructions here are to identify what will give us a solution with a pH close to 7, and then to rank these from lowest to highest pH. So the one that I'm sneaking in on you here is CO2. Carbon dioxide actually reacts with water to produce carbonic acid. So CO2 dissolved in water actually becomes H2CO3, which means that this will be an acidic solution. It is a weak acid because it's not on our strong list. Everything else I think we know how to handle. KNO3 is going to be a salt. All right, the K comes from KOH, the NO3 comes from nitric acid, KOH is strong, nitric acid, HNO3 is strong, so this is going to be a neutral salt. So that's probably going to be our answer here for the pH closest to 7. But let's investigate the other ones. Ammonium iodide, well, that ammonium ion came from a weak base. The HI came from a strong acid, so this one is going to be an acidic salt. And then let's see, ammonia is a weak base. And then the methylamine is also a weak base. Okay, so based on what we know right now, if we're going to compare carbonic acid, well, the things that we have that are on the acidic side are carbonic acid and ammonium iodide. Since carbonic acid is actually an acid, I would go ahead and rank that as being the lowest pH. Then ammonium iodide being an acidic salt, I would put next. Then I would put our neutral salt, which was KNO3, followed by, we've got 2 weak bases. And we didn't really talk about how you would determine between ammonia and methylamine which one of these would be weaker of the 2 weak bases. So we would just put those both at the same level. So we'll just cram them here on the end, ammonia and methylamine. All right, so the one with the pH closest to 7 is potassium nitrate. We had a weak acid, an acidic salt, then a neutral salt, and then 2 weak bases in our rankings. So circling back to our objective, instead of calculate, what we're really doing here is more like classifying. So classify the pH range of salt solutions. I'd expect you to be able to determine if a particular salt is acidic, neutral, or basic. And if it is neutral, the pH is 7. I'm not asking you this semester, for spring of 2021 only, to give an actual number for the pH of an acidic or a basic salt. Just classify it as acidic or basic. A neutral salt comes from a strong acid reacting with a strong base. An acidic salt comes from a strong acid reacting with a weak base, and a basic salt comes from a weak acid reacting with a strong base. Then the salt that is produced for any of these reactions has the potential of reacting with a molecule of water. The neutral salts do not. But in the case of the acidic salts, the protonated weak base wants to give away that extra proton. When it releases that, the presence of those H3O plus ions makes the solution acidic. The basic salts, what happens is that the weak acid doesn't want to stay in its deprotonated form, so it steals a proton from water. And when it does that, what's left behind from the water molecule is a hydroxide ion. The presence of that hydroxide ion makes the solution basic. So I'd expect you, given the formula of a salt, to be able to reverse engineer it. The cation came from a base, the anion came from an acid, and then you just simply classify them, and you use the chart that I just sketched out here to determine if it's acidic, neutral, or basic.